Hey everybody, welcome to this week's CanJS Community Hangout. This week we have two presentations, one by Eli. Say hi, Eli.
Hello.
And Eli's going to be telling us about the CanJS can.Map.define plugin. And so hopefully we can all learn how to use that in our projects. I know I'm looking forward to it. And then Matthew, say hi, Matt.
Hey.
Matt's actually going to be explaining to everybody how to make SystemJS plugins, which is great because I actually needed this earlier this week, and Matt was kind enough to build it for me. But it'll be much better to know how to do it on my own. So without further ado, I'm going to go and hand it over to you, Eli.
Alrighty, I'm just gonna share my screen real quick here. So I've got here a JS fiddle that's just got a whole bunch of JavaScript in it. Setups that when we log, it'll log output out to here. So what we've
really
got
fast.
here.
Sorry to interrupt. I was just going to say, if you want, introduce yourself real fast, so people know why we should even be listening to you.
Oh, I guess that's a good idea. I'm Eli Morris-Heft. I've been with Bitovi for almost 2 years now, just doing the JavaScript thing and keeping an eye on stuff. I've got some articles under my belt and a bunch of experience. So that's me in the technical sphere. So first thing that we're going to do is this is going to be a pretty basic introduction to the define plugin. Although there's some cool stuff that you can do with it. So first thing we're gonna do is we're gonna extend a can map. So essentially we'll create a type of can map, and in the static properties we'll give it a static property called define. So in define, you list the keys of the object that you assign to define are the names of properties that are on your object. So we've got an active entry property, a per page property, a page property, which is a little weird. We'll get to that in a little bit, and a bookmarks property. So this is like keeping track of where you are, like in a set of paged results or something like that. It's a demo, so obviously the stuff is a little contrived, but it'll do for us. So for example, you see we have a per page property defined here, and that's one of the things that we pass in when we create a new paginator. So this is actually one of our properties. So the define plugin has a number of things that you can define for each property. You could define a default value, so our active entry. So maybe we've got a list of 100 search results and we want to know which one is the active one. So our default value for our active entry is 1. And when we do a new paginator, you'll see if I run this, that the active entry automatically gets assigned 1. Now we could have just passed it in here, but this lets us not do that. You could also do getters and setters. So we have a setter on the active entry that makes sure that when you pass in a value, that value is never going to be less than 1. Because if you have a number of search results and you want to have an index, it probably should be a 0-based index. But for this, we're going to ignore that. So this makes sure that you never have a negative active entry for that. We'll get to getters in a second. They're a little more complicated. And then the other nice thing that you can do is you can have a type on your property so that anything that comes in gets coerced. And there are a couple of shortcuts for the type. For example, this per page, which is, for example, in this, it might be how many search results you show on a page, should always be a number. And then with getters, we'll get to getters in a second. So you can look at the active entry, and it will it will tell you, we've got default of 1. For pages, page is not like an actual property on the map. That is, it's not stored, it doesn't have a value. But we can ask for page using attr, and it will run this getter and return what we need. So we have how many things there are per page, and we know which one is our active entry. And so this will tell us what page we're supposed to be on, using those two to compute, rather than sort of storing it by itself. So we can say if we're active entry is number 1, then of course we're on the first page. If we change the active entry that we have to 34, active entry number 34 is going to be on page 4. So that is what the get does in the define plugin. It's actually kind of nice for those computed values, and you can mess around with this. Here we are trying to set the active entry to something that's out of range. So -20 is out of range, and it, as you can see, resets it to 1, which is what we've asked it to do. So here, on per page, up here, we have a type, and the type says number. So anything that gets set to per page is going to get coerced. To a number, and it'll essentially get run through parse float. So if we try to set per page to something that doesn't make sense, like foo, then running it through parse float is going to get us nan, which is not the best. So we maybe want to do something a little bit different. You can pass these strings, there's number and string and boolean and a few others, to type, or you can provide a function for per page, or for the type, where it passes the value in and you do whatever type coercion you need to. So in this case, if we get a nan, then we're just going to default out to 20. If I run this, you will see we've defaulted it back out to 20. The other thing that this is kind of nice for is, you see I've got a bookmarks property that starts out as an array, and we can give it a type so that we could pass in, let's scroll down here a little bit, we could pass in either an array of things or a comma-separated string of things. And it will be able to detect in the type coercion function whether it's one or the other and do the right thing. This is really useful for when you're bringing things back from a query string. If you're using can.Route or something, you're using a define plugin with your can.Route data map. This is a really nice thing to be able to do because you can sort of set it as an array, and then when the route changes and it's comma separated or something like that, it will come back and go through the same function. So this is a nice place to get that done. And then you can see that in set we just make sure everything is an int before we put it in this bookmarks. There's a little bit of overlap between type and set in terms of when they get run. There isn't sort of a great way to distinguish between one or the other, except for a thing that I will mention down below with type. But it's sort of semantic. You have to sort of figure out which one makes sense. Here I've decided to separate it like this because the type function to me is about just making sure that everything is coerced to the right type, and then set is sort of about making sure that the data gets set correctly. You can also, by the way, use set sort of in a parallel function out from get to change other values in the map. So I might add a setter to this page that says when we set the page, it'll figure out what the first active entry on that page was and change our active entry to that. That's a thing that you can do in setters. Going to move on a little bit and talk about type and value a little more. Just going to comment these out so that they don't affect what we're looking at. Here I have everybody's favorite, which is a tasks, which is a tasks thing. It just has a list of tasks in it. First thing we do is the default value is a new can list, and the type coercion, when you pass it in, it always coerces it to a list. There's also remove, which when a property gets removed using remove attr, this is a function that's run. And serialize we'll get to in just a second. So this works pretty much exactly how you'd think. You make a new taskinator, and then t.tasks is in fact a list because that's what we've got. But we do have a thing on the define plugin that you can shorten this up a little bit, and you can just, for a type and value, if you capitalize them, you can pass in constructor functions. And so we can just say the value of this starts with a new can list, and type always coerces to a can list.
Yeah, I think you have to do it that way, Eli. I mean, otherwise value would always be the same instance. It would be the same list for every taskinator.
I was just about to mention that.
Oh, sorry.
Yeah, no. It's good. It means that we're thinking along the same lines. That's what the use case for these is if you had a lowercase v value like we did before, you would have the same list as the default starting value all the time, which is 99.95% of the time not what you actually want. The last thing that I'm going to talk, remove is pretty straightforward. The last thing I'm going to talk about is serialize. So maps can be serialized. You just call .serialize on them. And if your property in define has a serialize function, instead of doing the default serialization, the map will run this serialization instead. So here we're taking all of the tasks that we have, do dishes, make bed, and we're going to join them with a pound sign because everybody loves pound signs. And you'll see over here that it does that, which is not surprising, but it is useful, and we'll see why in just a second. I should note, though, that this is only if you're serializing the map itself, or if something, if you're serializing a map that contains this map. If you go to the tasks property directly and you ask to serialize it, it's going to serialize according to its own interior logic. So that's this when you serialize the list itself, and then when you serialize the object, it knows about the things that you told it about in define, and it does it the way that you want it to. And then the last thing...
Maybe a rookie question here. So using the define, can you add any other method to your attributes, or just the serial, like these predefined ones, like serialize, remove, type, set?
It's just these predefined ones because they happen at certain points in the data lifecycle, right? So value gives you a default value to start out with if you don't provide one. Get is when you use attr to get the attribute. Set is when you are setting the attribute using attr. Type is any time that when you're setting it, it coerces the type for you. And then serialize, well, remove when you remove attr, and then serialize when you are serializing. So
Eli, do you want to look at the docs page real quick and show the type def?
So here's the docs page. These docs are pretty simple to go through, but if you want the cliff notes, down here is where you're looking. The value, get, set, serialize, remove, and type. And then value and type have their capital letter versions, which are when you pass in constructor functions. Last thing I'm going to do here is I'm going to have some fun with serialization. So Just going to run this real quick. So I've got Nameinator, because we had Paginator and Taskinator, so of course it has to be Nameinator. Nameinator gets a first name and a last name. And for our first name and our last name, we're going to return nothing from the serialized function. What this essentially does is it says we don't want this, or we're going to return undefined. And it says this property, we don't want it to be in the serialized version. So right here, when we do an adder, we'll get these properties. But when we do serialize, we won't get these properties. So that's this first thing.
Eli, isn't that the same as saying serialized false?
I think it has to be a function. I could run a double check.
Same thing, actually.
No, I think you can be false. We use that to keep stuff off of our routing.
Okay. So you could just do false here. We also have a thing here that's just name, which when you get it, it's supposed to return somebody's full name. So you could do this. Then you'll see returns that, but it isn't returned in the serialized version. So get and serialize are different in that way. Serialize won't prevent it from showing up in adder, but it will prevent it from showing up after serialize. And then get doesn't have it show up in either. If I wanted this to show up in serialize, I have to give it another serialized function. Run this. Now it will show up in serialized. The last thing that I want to point out, which this was useful in a project that I was recently working on, is that you can change define on the fly. We had a thing where we had a couple of search dimensions going on, and we didn't know what they were going to be called until we got some info back from service layer. And we were able to make definitions based on what those were supposed to be called. So you could just hook right into the define property, the prototype, and add something else. So in this case, we're going to add a thing called phone book name, which says last name, comma, first name, and give it a serialized definition. Probably should also give it a get definition. But you can do adder with after we've added this, and you can see that it's exactly the same. This hasn't changed. But when you serialize, you get both the name and the phone book name. And that's pretty good first tour through define. It's one of those wonderful things that's very that's sort of very simple to start using, and then you start saying, oh yeah, I think I'd like to use that in more places. It can end up being very powerful just because it gives you some tools that help you out for some really specific situations.
Nice job, Eli.
Yeah,
I would say that in my experience using define, it's nice architecturally because a lot of the logic that you're going to end up putting in serializers or getters or remove hooks were things that had to be kind of in the application code layer before, but it belongs really in the data layer. And this gives like a real semantic location that it belongs in. So it helps clean up your code, I think, in ways that you might not expect until you start using it.
Yeah, it also helps in two big ways. It puts those things, it puts all the information about a certain property in one place, so you don't have to go through overriding the serialized function and that sort of thing. And then the sort of computed get properties, the virtual properties, are very, very useful because then you end up not having to sort of put everything in computes or making little functions for everything.
Yeah, Yeah, by virtual properties, you mean properties where you're not actually storing the data, but calculating it from other properties that are actually.
Right.
Yeah. Yeah, those are useful for sure.
Yeah, since I started using define, I don't use regular computes very as often anymore, anyways. More when you have some special need for them, I guess.
I mean, often these functions get turned into computes because
right.
we're using them in a template, and that might actually be worth mentioning is that if you use like the name property inside of a mustache template or a stash template, that will get converted into a compute. So if you're accessing properties using adder inside of one of those methods, it'll be dependent on changes in those properties, just like any other compute. So it's just kind of a nicer way to define them.
Yeah, it's a little more transparent.
Yeah.
Very cool. Thanks, Eli. I can actually say I'm one of the people who has not used this yet, and I'm very glad he gave this presentation because I'm going to definitely use it probably the second I get back to coding. So, so thank you. And then on to you, Matt.
Hey, so I'm going to create a SystemJS plugin. Hopefully, this could either take a really long time or not that long at all. We'll find out. So the idea, SystemJS, maybe I should start there. SystemJS and SteelJS. SteelJS is built on top of SystemJS. SystemJS is a module loader that follows the upcoming, well, there's ES6 module loader, which follows the upcoming ES6 module loader specification that will be in browsers soon. SystemJS builds on top of that. It gives you the ability to define modules using AMD, CommonJS, ES6 syntax, or you can actually add your own syntaxes on top of that, which is one of the things it still does. So it's a really cool project, and one of the best things about it actually is that it's very easy to create plugins for. Ridiculously easy and very powerful too. You can create plugins that hook into all different parts of the module loading lifecycle. I have a couple of slides. I'm actually doing a presentation about this later in the month, and so you're kind of seeing the raw first version of it. Hope you all can see this. So I have a couple of slides. I'm going to skip a couple of them. But today we're really talking about loading modules and writing plugins that can change the behavior of the module during the loading process. And to do that, we tap into different hooks that SystemJS provides. So I'm going to go over those hooks real quick. They are normalize. Normalize is a hook where it allows you, or what normalize does is it converts a module name into the fully normalized module name. So, for example, if you use steal, you might steal can.Map, right? Everyone has done that before. But when normalize goes through the module name, it converts it to can.Map because the location of can.Map of the module is actually can.Map/map.js. It would also do stuff like this, where you have a relative module ./utils, and that becomes app.utils because we're in the app folder. So that's normalize. Normalize is extremely useful, actually. You can do a lot of advanced stuff with normalize. Locate is not less. It's less interesting, I would say, or at least I guess I should say I haven't really figured out what to use it for. But what locate does is it gives you the actual path to a module. So if you're running in your local machine, it's going to be HTTP localhost, whatever the path is to the actual file. Fetch is an interesting one. Fetch gives you complete control over fetching the module. So by default, SystemJS fetches modules using XHR, using an AJAX request, but you can tap into the fetch hook, and you could fetch some other means. Like perhaps you want to load an image, and so use an image tag instead. So fetch is awesome. Translate is the one that we're going to do today. I don't know if I said this before, but the thing that I'm going to be coding is a markdown to CanJS to a can.View render function. It's a mouthful. Can.View render function is I'm sure everybody's used can.Mustache or can.EGS or can.Stash. So when you use the syntax, for example, can.Stash and then a string, it returns a render function. So we're gonna take a markdown file and convert that into a render function. And to do that, we're going to use translate. What translate does is it takes the source and you translate it to some other representation. So for example, if you like CoffeeScript or any other language that compiles to JavaScript, if you want to make a plugin for that, you would tap into translate and you would do your compiling there. There's a couple. This is less interesting, but a couple of rules surrounding translate. If you return undefined, it will just keep going through the rest of the process as if expecting that the source has changed. Oh, by the way, so all these hooks take in a load argument, and the load argument has the source code. It has some other metadata surrounding the module. Then if you return source, it will exit the loading process. That's not super important right now. So that's translate. That's the one we're going to be doing. There's also instantiate. So that's the final leg of the module loading process. And this is where you actually instantiate the module. So anything you return here becomes the module value. But we're not going to use that one today. A very important thing to remember when you're writing SystemJS plugins is that all of these hooks can return a promise. And what that means is that you can do any type of async behavior inside of the hook, and the value won't return until the promise resolves. So for example, normalize, this is really useful because you might want to import some other module, and system import returns a promise. So you can import some other module, do your normalization, and then it will return. Okay, so that's it for the slides. We're gonna, like I said, we're going to create a markdown to CanJS can.View render function plugin. Yes. All right, let's get to coding. I've already installed some stuff in Bower because I didn't want to bore you with that, but my Bower JSON is pretty small, my dependencies. I have CanJS in a special branch. Ignore that. This is all going to be in CanJS's minor branch shortly. But I have a marked, which is my markdown to HTML converter. I have jQuery and I have Steel. So because I'm using Steel, I only need to add the Steel tag here. So the path to my Steel is Bower component Steel. I think it's Steel.js. We'll just guess. Then I'm also going to specify a config file. By default, it will open steelconfig.js, but I want to be different, so I'm going to call it config.js. And then we're going to specify the main module, and this is the module that will run as when everything kicks off. So that's all I had to do there. Create a new file, and let's do our config, because that's easy. So the config file, if you used steel config before, you can do steel config and put in all the options that you would do here, paths, for example. I'm not going to do it this way because I just want to, because we're trying to start using system object instead. So you can set your paths, you can set your map, you can set what used to be called in the old steel shim is now metadata. Is system.meta. But really, I only need to set the paths for this. So system.paths. I'm going to give the path for can stuff because can is going to load a bunch of stuff. So can is in $, components, CanJS, startup.js. What this is saying is that anytime a module called can whatever is requested, this is where you can find it. So if you load can.Map, it's going to look here, and then this is the wildcard replacement. What else do we need? We need jQuery. jQuery is the actual module name. Some quotes. I don't know where this is located, but I think it might be here. And then marked. So marked is, like I said, that's the library that we're going to use to convert Markdown to HTML. And I think this might be it. I don't think there's anything else. The app will break if I'm wrong. Yeah, you can also, well, I'll get to that in a second. So we have our config file. Now we need to create our main module. And we're going to do that. This is going to be our main.js. All this is going to do is it's going to load in the readme.markdown. I don't know if I showed you this before, but this is just a simple markdown file. It's got links, it's got lists, it's got bold and italics. So we're going to load that in, and then we're going to render it. So we'll call that render, since it is a render function. Oh, by the way, I'm using CommonJS, as you can see. Readme.markdown. Okay, this might confuse you a little bit. What's happening here is that we're saying load readme.md, markdown, then bang in MD. What that means is this is the plugin that we're going to use. The plugin is going to be the module MD. So if you use Steel has the ext extension. So you can do something like this, ext, and then you say MD, and then you give the location to MD. So that would work. But I'm not going to do that. I'm just going to, just because I want to explain how SystemJS itself works. SystemJS is you specify the plugin module name. Now I also need jQuery just to put it somewhere in the page. Let's give a place to put our rendered markdown. All right, so this is not very much code here. We're just going to set the HTML of content to whatever render produces. Okay, that's all you have to do there. So now we need to actually, let's go ahead and load the page and see what happens. It's going to complain that it cannot find md.js. That's our plugin. So it's already at this point trying to convert the markdown file using this plugin. So we need to write the plugin. Like I said before, oh, don't complain about that. I don't actually use Sublime, so that's why that happened. Again, I'm going to do this in CommonJS. So like I said before, we're going to use the translate hook. So all we have to do is export a translate function. The function takes in a load. And load has a source property, load.source. And that's going to be the raw markdown string. So what we want to do is we want to convert that. So to do that, we're going to use marked, which is like I said, it converts markdown to HTML. So we can say var HTML equals marked, load.source, and just set it This is going to be very wrong. Let's set our debugger here so we can see how badly we've done. So we can see now that we do have HTML. So it's gone through marked and it's been converted to HTML. We have a problem though, namely that there's all these line breaks, and that's not gonna work because eventually we're gonna convert this to JavaScript. So in order to do that, we need to fix that. We need to escape all of those. Luckily, the stash plugin does this exact thing, so I can just steal the code from it. But basically, all this is doing is it is escaping all of the new line characters and some other special characters. I think one of these is like the paragraph character. So all we have to do is escape it, and then we'll have just a nice one-line string. Let's see if that worked. Yeah, it worked. Okay. So at this point we have the HTML as we want it. However, we don't want to return HTML because we want this to be a render function. So in order to do that, we have to return a string that will execute as JavaScript. So this module that we're creating is going to depend on stash. So let's go ahead and import stash. Our stash equals require can view stash because that's where stash is. Let's create a new line just so that we can see it in the debugger tools. So we're going to require stash, and then we're going to set our module to equal the value. Again, I'm using CanJS, just fewer characters. And then, so the value of our module is equal to stash. That's the HTML. This is right. That looks right. So if we do this now, this might be it. This might actually be everything that we have to do. Hey, look, it worked. So let's set a, well, actually, let's look over here. You see in my developer tools, I have a readme.md in one of my sources. If we click on that, we can see that we have a module. The module requires stash, and then it sets its exported value to stash, and then this big O string, which is the renderer function. If we set a breakpoint here, we can see that renderer is a can view. Well, we're using stash, so it's a can view renderer function. Call it. It returns a document fragment. It has our HTML. Yeah, this is all because I was using CommonJS. This is what SystemJS wraps around CommonJS before it executes it. But as you can see, we have rendered Markdown. So if you want to develop some type of blog platform, client-side blogging platform using CanJS, this is possibly something you could use. I hope this demonstrates that you can do a lot with SystemJS plugins and not a whole lot of code, and you can really tap into many different parts of the module loading process. I think that's it, guys. Is there any questions?
None for me. I don't see any from the community. One thing I know you already touched on this before, but just for anybody that didn't catch it before, you can use this to load less files, SAS files, coffee files, any type of file you need that kind of needs some pre-processing before being brought in.
Yeah. Yes, that translate is really good for that particular hook. Well, that's what it's for. That's whenever you're thinking of plugins that you want to create, that's kind of the obvious thing. But you can do really advanced stuff as well. I don't want to get into. There's a difference between in my opinion, between plugins and extensions. And extensions, you can do even more powerful stuff. But as a way to start, definitely in projects, you should be thinking about whether this could be useful to you.
This might be a stupid question, but that's okay. So this API, if I'm not mistaken, is like a standards-based thing that browsers eventually will support?
Well, I'm not the best person to answer that, but a lot of this SystemJS stuff is not. It's SystemJS's. I don't think plugins are going to be part of the browser API. The module loading will be. So there'll be a system loader, and there'll be system import, which you can use to import modules. But I don't believe plugins are something that are going to be standardized.
The system construct itself will be native in most browsers.
Yep.
And is that in anything now, or is that still just a standard spec?
Oh, I don't believe it's. I'm sure Chrome and Firefox will have it first, but I don't think either one of them have it yet. So with the standards, you're going to get system import. You're going to get the ES6 syntax. I could have written this in ES6, but I'm just not as familiar with it, so I didn't want to screw it up in the demo. But you'll get that for free with browsers. So it's really cool, though. What's cool about that is you have the standard ES6 syntax. Why don't I just show it off a little bit? So I could have done like this main file in ES6, and that would have looked like import render from readme.md, like that instead. I've done the same thing for jQuery, and this is statically determined. That is, the browsers, before it executes the file, it knows what you're going to be importing and makes sure that those are available. But you also have system import, which is dynamic, which means you can do stuff like some variable plus foo. You can do stuff like that, and that becomes useful. Like I said, when you extend normalize, then you might do stuff like this. Like you might want to define some type of special syntax where you can do import, maybe like request animation frame from Wraith, and you only want to do it maybe without, I don't know what a good name for this is. Maybe what this does is it checks for the window if the window has request animation frame, and if it does not, then it loads the request animation frame polyfill. You could do stuff like that. So using normalize, you would be able to change this, get the without. Maybe this is wrong actually. Yeah, you'd be able to break this up into a string and load request animation frame if it is not part of the window.
Gotcha. This is compiling this code right before it runs in the browser.
Well, if you use the translate hook, yeah, you're going to compile it yourself.
Right, but it's not. So can you go back to your code?
Yep. Like my markdown, right?
To your JavaScript that was running the renderer.
Oh, the main.js? Sure.
And also, we're not seeing your screen right this second.
Oh, that's bad. So you want to see the plugin?
Well, I just want to ask probably a stupid question just to make sure we're all on the same page on how this works.
Okay.
So this is going to compile this code, right? Because it has to actually asynchronously load that markdown file, run it through your processor, and then it has access to the renderer function. But this code looks like it's synchronous, but it's not actually synchronous.
Oh well, right, exactly. What it does in the background is it has regular expressions where it identifies which syntax you're using. So it's going to say, I don't know how these regexes work, but I'm sure they say if there's a require call, then it knows that this is CommonJS. So yeah, it's before this actually runs, it's going to get all of the all of your dependencies. You
Can
can
you
actually,
show,
you
can
have
you
to
show
show.
the compiled version?
Yeah, this is a compiled version. I wouldn't call it compiled. It's, well, I guess whatever. Yeah, so this is, it wraps this function, which gives you access to exports and module, require. This is all stuff that you expect from CommonJS. And then it puts it here.
Yeah, I guess I'm wondering how is require actually working though, because it's not actually loading that synchronously, running the export, running the translate.
Well, it's not executing. It won't execute. This won't be executed until it has all the dependencies. So I'm sure you can step through it if you want to. You can just step through this, and it already knows what your dependencies are, and it has their values. Does that make sense?
It has their values if they've been loaded already, right?
They will be loaded. It won't execute main until it has already loaded and executed both of these.
But how does line 7 get prevented from executing until line 4 and 5 have been resolved?
This entire file will not be executed until these have been loaded.
I see. Okay, gotcha. Right. So it figures that out ahead of time.
It figures out ahead, but you might want to load. Like I said, you might want to load stuff at runtime. So to do that, you can use system import, and then you can, like I said, you can say some variable plus foo. It couldn't statically do this, right? It wouldn't know what some var is until it actually runs.
But then would you have to use like an asynchronous callback to like say when that resolves? Then you
it returns a promise.
Oh, I see.
This is the value. That's the cool thing about all of this returns promises, so makes it really powerful.
I see. Cool. Thanks, Matthew. That was very easy to follow and useful.
Yeah, totally agree. Okay. Any questions from anybody? Any comments? Anything else? Otherwise, we will call this meeting adjourned. Okay. Sounds like it. Well, thank you to the viewers as always, and we will be back next Friday. Then we're going to take the next week off while Bitobi goes on a company retreat that we've all been patiently waiting for, and then we'll return as always after that. So until next week, and I'll talk to you guys then. Thanks a lot, Matt. Thanks a lot, Eli, and thanks Brian for joining as well.
Thanks everybody. Good job, Chris.
Thanks. Good weekend.
Thanks.